All right, y'all, here we go. A fixed container holds 2 moles of gas. Once you see it says moles, you know we've got to use PivNert, right? 40 kilopascals, so that is our pressure. See, I just wrote the formula down. The pressure's there. 8.314, that is the R for kilopascals. This is on page 1 of your things. 505 Kelvin, that's our temperature. So we solve this, take the 40, we're going to put it down there on the bottom of those three. Bam. Right? By looking at these, can we determine what gases are? No, not really. All gases act the same. Now, we could maybe make a guess later if we could weigh it somehow or we knew the grams, but other than that, you got no shot. A weather balloon at STP, that's standard temperature and pressure. So standard temperature and pressure, since we're using millimeters of mercury, evidently, 760 and 273, that's standard temperature and that's standard pressure. So we know this is a PV over T problem because pressure is given to us twice and temperature is given to us twice. So we set it up, P1 V1 over T1 equals P2 V2 over T2. We solve for V2, 55.7. All right, this next problem is PivNert. PivNert, we're given 0.5 liters. See, the volume has to be in liters, okay? 0.5. Moles right there. Since the pressure is not specified, you got to use atmospheres. That's what I want you to use. So that's the 0.0821. And then 318 is our temperature because 45 is 318. We're going to take the 0.5 and put it on the bottom. And there you go. All right, number 5. Number 5 right here, PivNert again, same problem. There you go, 1.7. It's in millimeters of mercury. So 8.314. And our pressure ends up being 2963. Again, we did that. Here's the P. Have to move the 1.7 on the bottom over here, right? 112 grams of C2H6. C2H6 weighs 30. So 112 divided by 30 equals 3.73. So, hey, saying. So, and so here we go. So 112 is 30. 312 divided by 30 means 3.73 moles. Bam. So this we had grams. We had to convert it to moles there. And here's our problem. It didn't tell us which pressure, so we used atmospheres. So 0.0821 is going to give us the answer in atmospheres. We're going to take the 1.2, put it right there. All right? There's your answer. Okay? Here we go. Container in problem number 9 is placed in the sun. Temperature goes up to 43. So now the new temperature is 316. It's the same problem again. Right? 80.6. Why are molar solutions always made by adding the powder first? If you put the water in first and you put the powder in, then the volume would go up and then you'd be off. We talked about that specifically in class. 200 grams of sodium fluoride. Well, what we'd have to do there is say 200 times 1 over 42 because that's 23 plus 19. It's 4.76 moles. So you have 4.76 moles in 700 milliliters. That's how many moles per liter? 6.8. All right. Number 10, 115 grams of magnesium sulfate are in 2 liters. So we go 155. So we go down here, 155 times 1 over 120.3 is 1.29 moles. Well, that many moles is in 2 liters of water. 1.29 moles is in 2 liters of water. That's how many moles per liter? 0.64. Makes sense? It'd really be 0.645. Number 11. 0.002 grams of carbon dioxide dissolved in 0.5 liters of water. Well, we had to figure out how many moles that is. 0.002 divided by 44 grams, because this is CO2, right? That weighs 44. Gives us 0.000045 in 0.5 liters. How many moles per liter? 0.00009 moles. And then number 12, a 12 molar solution of acid in 10 liters of water is diluted by adding 8 more liters of water. So we had 12, this is M1V1 equals M2V2.
Open up B112, please.
So
Open up B112, thank you.
M1V1 equals M2V2. So 12 times 10 is equal to what molarity times 18? Because we added 8 more liters to the 10 liters we already had. So now that made it weaker. It diluted it down to 6.67 molar from 12 molar. I hope that helps people.